Welcome to the lecture Python for Data Processing and Plotting. Today I'm going to give you a brief overview of Python language. I will also talk about briefly Numpy, Matplotlib, which is used for data plotting. The reason I'm talking about Python is that visualization requires a lot of data processing, for which Python is a great tool. So let's start it. So what is Python and why Python? Python is a dynamically typed language. It is very much like a C. However, one special thing that is different is that you do not need to declare a variable before using it. It has a large number of packages that allow you to do almost everything. So many routine tasks, you can easily find packages that are already done for you. So you do not have to implement from scratch. So because of this reason, Python is good for fast code development and prototyping. Because it's not compiled language, you can immediately run what you have just written. Python can do automatic memory management. That is, you do not have to allocate and deallocate your memory. This is done automatically for you. People find a feature of Python that is particularly convenient is that you can pass functions around as arguments. Python is still a little bit slow for data-intensive computation. So if you are performance conscious, you can always write your performance-critical segment of code in other languages such as C, and using Python to wrap around the code, and you can run and control your code in Python environment. Okay, so now let's see Python in action. So first of all, here I have variable x. Note that you do not need to declare x before you assign 0 to it. There are some Python built-in functions. Over here, I use print to give a value of x. So now let's pay attention to another statement. I have variable z. Now I want to assign a string to the variable. Like before, I do not need to allocate space for the string. I do not need to know how long the string is going to be. I just use a single quote to assign the string foo to the variable z. You can also use double quote if you want. For example, the variable w, I use double quote and assign the value bar to w. So here, this is the output if you run the commands above it in Python. And you can check the printout to see whether it matches what you expect. Okay, now let's look at the Python expression, which looks exactly like what you are used to in other languages such as C. So here I have three variables, x, y, z. Then I just use this infix notation to add together and print. You can also do the same thing for strings. So note that above R, S, T have value 1, 2, 3 defined as strings. Then I can print the sum, which is the concatenation of the three strings, which you can expect that the result is going to be 1, 2, 3 with no space. You can put multiple assignments on a single line if you want. Of course, this is not necessarily made the statements readable, but if you want, you can do it. So here I have three variables, B and C and D, and you can write three expressions that correspond to each of the variable. One thing to remember is that you can add numbers together or you can add strings together, but you cannot mix those two and add it. So if you say use this command, print x plus r, remember x is a number, 4, r is a string, 1. When you add this together, Python is going to give you an error message. That is, it is not going to do an automatic conversion for you. One data type in Python that is very useful is the list. So basically, list is like a vector. So inside the list, you can have multiple components. You define the list using a square bracket. So here, the variable x is a list. It has 5 numbers, 1, 2, 3, 4, 5. You can have a floating point number, you can have integers, anything you want. You do not need to declare. Here, for example, the variable z is a list of alphabets. You can even mix data of different types. For variable w here is a list. Then he has values 1, string 2, values 3, string 4 in double quote. You can even put a function here like a print. Note it is a function, so if you index to that particular element, you can actually run the function print. Now let's look at how do we acquire a subset of elements in a list. This is called slicing. So in the example here, we have a list W, which has 5 elements, 1, 2, 3, 4, 5. So you could take a arbitrary segment of the elements in the list using Python slicing. So here, I have a special notation here. I have a square bracket, which indicates the list W. And inside the brackets, I have a column here. Now, the number before the column indicates that where you want to start to get the elements. Python lists use zero-based indexing scheme, which means the first element will have index of 0. So index of 2 indicates value 3 in W. Now, on the right-hand side of the column, there's no value specified, which just means that you want to get the elements all the way to the end. So if you run this command print W starting from index number 2 all the way to the end, you are going to get the result 3, 4, 5. Now, you can also skip the first value, that is the value on the left-hand side of the column. So here we do not put any value here. That means you want to start from the beginning. Now, the value on the right-hand side too, of course, is an index, which means you want the elements from the beginning all the way up to before the element has index 2. So if you run this command, you get this W space colon 2, which means you want the element 0 and 1. So if you print, you won't get the value W, the first 2 elements, that is 1 and 2. Now let's look at how to use some of the control structures in Python, and also how do you loop through a list. So in the example here, variable z is a list, has 3 elements, 1, 2, 3. Now I want to loop through it, create another list, and the elements in the new list is 1 plus the element in the list z. So let's see how to do it. So Python has a for loop structure, which is actually very similar to many other languages. So here you say I have a for I in z, which means I have a variable here I. I'm going to assign every element in z, taking turns to the variable I. Here the colon here in Python indicates a block, beginning of the block. This is just like the curly braces in C languages. So I'm going to assign value 1 and 2 and 3 in the list at every iteration to the variable I. Note here that we do not need to declare the type of variable I. This is just a common feature of Python. Now you define the block in the for loop by using indentation. So that is, you can see that n.append, which is a append method to add an element to the end of list n, which is the new list. In the beginning, n is an empty list. You grab each value of the elements in z, add by 1, and append to the end of a new list n. So if you want to have another line of comments inside the for loop, then you just start a new line. But remember, you need to put a space, use indentation to indicate you want to continue the block. So if you print the value of n and z together, you will get the n list being 2, 3, 4, which is 1 plus the elements of z, that is 1, 2, 3. Now let's look at a new example. W is a list of lists. So it has 3 elements. Each of the elements in W is another list. So 1, 2 is a list, 3, 4 is another list, and 5, 6 is yet another list. So here I'm writing a double loop. So I'm going to assign I to iterate through every element in W. And because W is a list of lists, so every element here is going to be a list assigned to I. Because I is a list, I can create another list J to iterate through the elements in the list I. So what I will do is I'm going to iterate through every element in the list assigned to I, and I will convert the numerical value to string, and I will concatenate the strings together from the list in I and output to S. So essentially what it does in this red box is that I'm going to take every single numerical value from the original list W and convert that to string and then concatenate them together. So we will print the result of S. You're going to see 1, 2, 3, 4, 5, 6. Python also supports if then else statement, which is common in many other languages. So the syntax is very similar to C. So the example here is to test the value of x, y, and z. Also notice you can use the reserved words false and true just to give the Boolean value. So you can see the syntax is very much like a C, except we're using colon to indicate the beginning of the block, and also using indentation to indicate comments that belong to a block. And this ELIF is else if. So you can have a sequence of if-else tests. Another data type that is very similar to list is tuple. So tuple looks very similar to a list, except that we don't use square bracket. We're using parentheses to define a tuple, which is, again, an array of values. You can index the tuple in a very similar way as you index the list. For example, here, my tuple A is 1, 2, 3. Then A0 indicates the first element, which is 1. A minus 1, this is a Python convention, indicates the last element, which is 3. And you can slice a tuple just like the same way you slice a list. So here, A1 colon space means you want to get the second element all the way to the end, which is 2 and 3. So if you will print this line, you are going to get 1, 3, and 2 and 3 here. So the main difference which you need to remember is that tuples are not mutable, meaning they are constants. You cannot change the value of element in the tuple once they are defined. So in this command, when you say A0 equal to alphabet A, meaning you want to change the value from 1 to A, you're going to get an error. Python also defines a very useful data type called dictionaries. Dictionaries is very similar to maps, hashes, associated arrays that define in other languages. So basically, a dictionary has a sequence of key and the value pair. So now I'm defining a dictionary A. Note that I use curly braces to define the beginning and the end of the dictionary. Here, the first key value pair consists of string 1 being the key and value 1 being the value. And I can have arbitrary types of elements as the key. So in the second pair, numerical value 2 is the key, and then string TWO now becomes the value. Third, I can even use function as a value. So in the third pair, the string print is the key, and the function print is the value. So if you query the value that belongs to a key, you simply use the name of the dictionary, which is A, followed by square bracket, and then put the key in the square brackets, then it will return you a value that corresponding to this key. So in this example, you will get 1. Now, because, like I say, the value in a dictionary can be a function, so in this example, when I say A square bracket print, which is a key, it will return a function back to you. So this is equivalent to a macro. You use a function print to print the string, high layer, etc. So this is the result. So finally, you can actually loop through a dictionary. Here, I use variable k to loop through the dictionary A. Now the k is going to be assigned to the key in the dictionary. So in the first iteration, the variable k is going to receive the key string 1. Then you query the value corresponds to the key by a square bracket of k, and k is already assigned a value of the key, so you can get a value pair. So the result, you can see that we are looping through every key value pair, which is 2 and the string 2, and print, string print and the function, and also the string 1 and the value 1. You can also query whether a key exists in a dictionary. In this example, you are asking whether a key, this string, is a key of the dictionary A or not. And if you check the value of A, you're going to find out the dictionary A doesn't have a key named a key. So you're going to receive a false value return. Because this string, a key, is not actually a key in the dictionary, if you try to query the dictionary using a non-existing key, you're going to get an error. In Python, you can define functions. So the syntax of a function is to start with def, meaning define, followed by the function name, and also use parentheses to include arguments to the function. So in this function, xyz essentially return the input parameter x twice back. So now if you call the function, which is the same way like you call a function in many other languages such as C, you pass a value 1 and it will return 2, 1 back to you. Then if you print it, you're going to get 1 and 1. File I/O in Python is also pretty straightforward. Essentially, you open the file. Here, I want to open the file named foo.txt, and you indicate that you want to write to the file. Then the function is going to have a method called write. Then you just call f.write and give the string that you want to write to the file, and then close. To read back in, the same way, you open, indicating that you want to read the file, foo.txt. Then you use the method read, indicate how many words you want to read back into S, then you close. Now after you print S, you're going to get this high layer, which is the string that you just write to the file. Okay, this is it. So I have just given you an overview of Python syntax. I hope you feel it's not that difficult to write a Python program. If you have never done before, now it's time to write your first Python program. So in the following, I'm going to briefly talk about 2 very useful Python packages for scientific computing and data analysis. Like I say earlier, there are a large number of Python packages that can do a lot of things for you so that you don't have to start from scratch. So the first package I want to mention is Numpy. So Numpy is the most popular package for scientific computing. It has very efficient mechanism to process multi-dimensional arrays, and also it has many linear algebra data transformation routines that you can use. You can get more information from Numpy in the website www.scipy.org. So to use NumPy, assuming you have already installed it, the first thing to do, of course, is to import the package. So in the example here, I have import NumPy. So I will show you a few examples of how the NumPy manipulates multi-dimensional array. One thing that makes NumPy special is that it's very efficient processing a large size of arrays. Although you can pretty much manipulate arrays in Python, but NumPy is going to give you much better efficiency. So here I show you an example that I declare an array ALBL, and each of the arrays has 1 million elements. Now the code in the square box here is using Python to add these two arrays together and assign to CL. And I measure the time here. So you can, by the way, learn how to do timing for your Python programs. So the next, I'm going to declare A and B, which are two NumPy arrays. So the syntax is you start with the package name, NumPy. You define a NumPy array by calling the method array. In this example, I use this special function called range, which essentially gives you a sequence of numbers from 0 to 1 million minus 1. So I declare two arrays of 1 million elements, A and B. Note that here I'm using NumPy for A and B. And I'm going to add those two NumPy arrays together, assign to another array, C, which is also a NumPy array because A and B are NumPy arrays. Now, if you look at the time in the bottom, you're going to realize that NumPy performance is several hundred times faster than the same operation of adding two arrays together if you use Python. Now let's look at some very basic NumPy operations. So one thing I want to mention here is the reshaping function. So in this box, so initially A is a NumPy array that has 8 elements. It's a 1D array. Given the 8 elements, I can reshape into any dimensions that I like. So I call numpy.reshape, and the input argument is the array A. Now, I want to reshape this 1D array into a 3-dimensional array that has dimensions of 2 by 2 by 2. So after this reshaping, if you print the array A, you're going to find out it's not a 1D list anymore from 0 to 7. Instead, it is a 3-dimensional array with 2 rows, 2 columns, and 2 stacks. Python can also do something so-called broadcasting. Broadcasting is basically if you want to apply an operation for 2 arrays, if they don't have the same size, Python is going to do something called broadcasting. That is to replicate or extend the array of smaller size to match the larger array. So here, this example, A, which is an array of 4 elements, and also we reshape it. So now it's a 2 by 2 matrix. If you want to add A by 1, but obviously 1 is only a scalar value, NumPy is going to broadcast 1 to make that into a 2 by 2 matrix, and then we add together. So now every element of A now is a original element plus 1. Now let's look at another example. So V here is an array of 2 rows and 1 column. Now if I want to multiply A with V, then clearly V has different dimensions. What NumPy does is to broadcast the first column into the second column, and then we do a element-wise multiplication. Now let me just give you another example. So now I make a V array into a 1 row, 2 column. Now I want to do A, which is still a 2 by 2 matrix, minus V. Now again, A is a 2x2 matrix, V is a 1x2 matrix. You cannot subtract them. So what Numpy does is to broadcast the V array, that is to copy the first row to the second row to make it a 2x2 matrix so that you can perform this subtraction operation. And of course, the reason why Numpy is so popular is because it has so many linear algebra algorithms already coded there. If you look at the box here, for examples, given two arrays A and B, you can perform matrix multiplication, outer product two matrices. You can compute QR factorization, singular value decomposition. You can also calculate eigenvectors and values for a given matrix, and you can invert the matrix, etc. There are many operations that you can do, so please look at the menu of Numpy. File I/O for Numpy is pretty straightforward as well. You open the file, indicate that you want to write as a binary file. Then you call this method called toFile. So F here is a file handle. Then A is a Numpy array. Then you just write the array directly to a binary file. If you want to read back in, again, you open the file foo.bin that you just wrote as a binary and read-only file. You can read the Numpy array that we just wrote to the file back to a variable A, which is going to become a Numpy array after the read operation is completed. You do not need to specify or declare the size, the type of A. A is going to be the same as the array that you just wrote out to the file. Okay, the final thing I want to talk about in this overview video is Matplotlib. So Matplotlib is a Python 2D plotting package. It does things very similar to what MATLAB can do for you. So I will only give you a very high-level overview. You can check the website, matplotlib.org, get some more detail. Matplotlib can help you to produce high-quality figures for multi-dimensional arrays. So to do that, of course, you need to make sure that you have Matplotlib package installed to your Python. You can check the website to get some more detail how to do that. And then in your Python program, you need to import the package Matplotlib. So in the example here, I say import matplotlib.pyplot, which is a package for plotting, and I give a name of my choice. Here I say plt. So this example to show you how to draw a line graph using Matplotlib. So first of all, I declare a NumPy array, which is a 1D array of 20 elements that has random values between 0 and 1. And then I call plt, which is my Matplotlib package. Then I call .plot, and I provide the array as an input argument. And after that, you call plt show, and you're going to see a window with the line graph. So you can use Matplotlib to plot 2D images. So in this example, I declare a NumPy array A that has 10,000 elements, and I reshape into 100 by 100 2D arrays. Then I call a Matplotlib image display method called IMS. Then I call a Matplotlib image. Then I call the Matplotlib image display method imshow and return a variable img. Then I add a color bar to this img, and then finally I display the image. So you can also display histograms using Matplotlib. In this example, I declare a NumPy array of 10,000 elements with value randomly distributed between 0 and 0.1. And then I call the method .hist, where I want to create 64 bin and using bar charts of green color, then with 50% opacity. And after that, I call plt.show, then you're going to see this histogram plot. Okay, so that's about Matplotlib. It is a very powerful tool. I hope you can find resources to learn more about how to do simple plotting using Matplotlib. So this concludes my overview of Python. I hope you find this useful as a starting point. Also, I hope you feel the syntax of Python is very easy to learn. Like I said, you have never done Python programming now, it's time for you to start writing your first program. Thank you.